Hello, let us talk about series resistance connections. So we'll try to understand how series resistance can be connected together to find an equivalent series resistance. So as you can see, what we will do is we will try to find out series resistance understanding. Then we will have voltage across each of the resistors. Then we will also see voltage division methods, and then we will see some of the example questions. All right. So as you can see, let us take an example of two resistors are connected together, R1 and R2, in a series. So series means they are connected in line, right? So by voltage loop equation, what is that? Kirchhoff's voltage law, that my Vs is going to be equal to V1 plus V2. This is the understanding that we have. And according to my Ohm's law, you already know that V is equal to I into R. That is, voltage is equal to current into resistance. So as you can see, the voltage across this V1 is nothing but the current across this resistor I into R1. Similar to that, V2 will be I into R2. So can we write it down? My Vs is going to be equal to I into R1 plus I into R2. Now, if we take I common, then we are going to have Vs by R is going to be R1 plus R2. And this is almost looking like, if I tell this R1 plus R2 put together is going to be RS, which is shown here as RS, then in this particular diagram, we can write it down. The current is nothing but voltage by resistance, or voltage equal to current into resistance, right? So I can write it down. My voltage Vs is going to be I into R. So similar to that, we have here Vs by I. So Vs by I is what? Rs. So Rs going to be R1 plus R2. So this is the equivalent resistance of these two resistors that you are going to have in a series connection. So this is very simple. All right. Now our understanding will be, what is my V1, what is my V2. So V1 is simply I into R1, V2 is simply I into R2. So if you know the current, across this particular like branch, then you can write it down. V1 is equal to I into R1, V2 is equal to I into R2. Now let us see another thing about this particular understanding, that I we already know, what is that? I is nothing but Vs by Rs, and Rs was R1 plus R2. So we'll replace that way, and then we will see voltage division method. Okay. So as you can see, my V1 is equal to I into R1, and I is nothing but Vs by Rs, and Vs divided by Rs is R1 plus R2. So if we replace that I, then we are going to have Vs into R1 divided by R1 plus R2. So this is my V1, voltage across resistor 1. Let us say in this particular diagram, plus minus, this is Vs, this is R1, this is R2, this is V1, this is V2, and the current flowing through this branch is I. Now now what I will try to make you understand is, this is also called as voltage division method. It means my voltage Vs is going to get divided across resistor R1, and similar to that across resistor R2, in the fashion that, see, voltage across R1 will be more if R1 is more, voltage across R2 will be more if R2 will be more. So similar to that, can we write down V2 I into R2? So my V2 is going to be I, that is nothing but Vs divided by R1 plus R2 into R2. So these two equations, you can now see that V1 will be more if R1 is more, V2 will be more if R2 will be more. So you have a understanding like Vs is going to get distributed in terms of V1 plus V2. So which one is bigger, V1 or V2? So my V1 is greater than V2 when R1 is greater than R2. My V2 is greater than V1 when R2 is greater than R1. Understood? So this was all about this particular voltage division method. All right. Now we'll try to also understand that the equivalent resistance that we found out, that was Rs. So Rs must be greater than or equal to maximum of my R1, R2, So if you have a n combination, it will be greater than all of them. Understood? So this is what we wanted to tell you. Now let us extend this particular concept for three resistors, and so that you can understand a particular behavior of this particular series combinations. Okay, so let us say series resistor. So resistor R1, R2, R3, R1, R2, R3, and they have been connected to a voltage source Vs like this. Now what will be the series combination of each of them? So can I write it down? Let us say the current flowing through this is I, and we already know if it is having a combination like this, like this. So this is my Rs. The current flowing through this is going to be I, and this is the source V. Then voltage is going to be I into Rs. Understood? So similar to that, the voltage across each of the resistor is, let us say, plus minus V1, then plus minus V2, and then plus minus V3. So can I write it down? My Vs is a combination of V1 plus V2 plus V3. Understood? Similar to that, my Vs is going to be equal to I into R1 plus I into R2 plus I into R3. Understood? And from here I can take I common, so it will become Vs is equal to I times R1 plus R2 plus R3. And from here we are going to write Vs by I am taking left side, is going to be equal to sum of all the resistors R1 plus R2 plus R3, and this is nothing but my Rs. S is the suffix for series resistance. Okay, understood? Now if you wish to find out what is the voltage across V1, V2, V3, then very easily you can write it down. V1 is going to be I into R1, V2 is going to be I into R2, and V3 is going to be I into R3, because the current into the resistance is going to be equal to the voltage drop across this. Now can you try to find out same method like voltage division method? What is the voltage across V1 in terms of only resistances and the input voltage, because I we do not know. So you already know right now that I is nothing but Vs by Rs, and Rs is a combination of this. So now it becomes very easy for us to find out that that my V1 is going to be I into R1 is nothing but what was I? I is total voltage, that is input voltage, by R1 plus R2 plus R3. So now you have a better idea of voltage across any resistor can be found out by voltage of the source multiplied by that corresponding resistor divided by total sum of resistance. Okay, so that's why you would have seen in the books lot of tips and tricks are given, or maybe many faculties also try to give you tips and tricks, that you give your input voltage, you give the corresponding resistors, and add all the resistors in the denominator. So you don't have to remember now you know the concept. Similar to that, V2 is going to be I into R2 is nothing but Vs into R2 by R1 plus R2 plus R3. Similar to that, can we write it down? V3 is going to be Vs into R3 divided by R1 plus R2 plus R3. So now if we extend this particular concept, then we can write it down a series combination of many resistors, let us say n resistors. Then we can write it down Rs is equal to R1 plus R2 plus R3, like that. Add all the resistors up to nth resistor. All right. And if we want to find out what is the voltage across nth resistor, let's say first, second, third, then we can write it down Vs into Rn divided by R1 plus R2 plus all the resistor up to nth. All right. So whichever resistance is the highest, that value will be highest. The voltage across that value will be highest. Let us take a very simple question and we will try to figure out how it happens. So let us say we have a resistor combination like this. Two resistors I am taking. One is, let us say we have voltage source as 12 volt, okay, and then let us say we have here 3 kilo ohm and let us say 9 kilo. So we have plus minus, this is let's say V1 and this let's say V2. So our aim is to find out what is the series resistance and what is the voltage across each of the resistor V1 and V2. So can we do it very quickly? We can find out my series resistance is going to be equal to 3 plus 9, that is 12 kilo ohm, right? Similar to that, we can write it down formula as well, R1 plus R2, where R1 I am considering the first one and R2 as second. Now we have Vs is equal to 12 volt and it is going to be how much? Let us say V1. So V1 is nothing but what? I into R1, and I was Vs by R1 plus R2 multiplied by R1. So this is going to be equal to 12 multiplied by R1 is nothing but 3 divided by 3 plus 9. So that is going to be 3 volt. Because 12 divided by 12 got cancelled, so only 3 volt is remaining. Similar to that, if you want to find out V2, that is going to be I into R2, or you don't have to write this formula again and again. You can directly write down Vs into R2 divided by R1 plus R2. So we can write it down as 12 multiplied by R2 is 9 divided by 3 plus 9. So that is again going to be 9 volt. And as you can see, my V1 is 3 volt, V2 is 9 volt, right? And my Vs is going to be equal to a combination of V1 plus V2 is nothing but 3 plus 9, 3 plus 9, that is 12 volt. And 12 volt is the source that is actually given. So basically, whatever the voltage that is given at the source must be distributed across each of the resistances. So hope you have a now very clear idea of how to calculate the voltage division methods and how to calculate voltage across each resistors connected in series. In the next session, we'll try to give you an example of parallel combination of resistors. Thank you.